I want to express my appreciation and your patient attendance and attention. I know it's, who would like this kind of stuff? I mean, I heard someone say the brain was going to explode, but yeah. Don't feel bad. It is a lot of material, and it's hard to soak it all in. And I do hope that you'll take advantage of the DVDs, and I hope those are successful and useful to you as an individual. I will tell you that I plan on getting a set because I have individuals that want copies. One of the high school science teacher that took my place wants one, and so I'll be getting one copy, and I assume they're not copyright protected by the Timberville Church of Christ. So I'll be making additional copies, as I have a DVD duplicator as well. We have one at the church, and I have one personally. So we'll be making copies, but I hope they can be of use to you. And as I said earlier, if there's ever anything I can do to help you answer questions in this area, in this regard, don't hesitate to let me know. I do use email not as often as some people like to see me use it, but I do use it, and so we'll be happy to help in any way possible. I will say this, not as a way of advertisement or as a way of trying to get a return engagement, but as you can see, I could easily, repeat or have additional sessions on the science of creation and never begin to repeat. This session on the Fearfully and Wonderfully Made is probably 4 hours worth of material if I were to spend any time on any depth. But I've also developed a series called The Science of Job, which I used last year in a congregation in Harrison County, West Virginia. And I used it at Beelington too in the adult Bible class. But it's an outstanding study, and not because I give it, because of what God revealed when He questioned Job. And so, like I said, if those are ever topics that are of interest to the congregation, I mean, it may not be the massive effort, but you never know if you start. There may be develop the interest if you've got contacts from this attempt. There may be interest in you never know. So I'm just making you aware of those possibilities. And we'll be happy to help in any way if possible. Fearfully and Wonderfully Made, the psalmist in Psalms 139, 14 through 16, reveal the fact that certainly he obviously realized that the human body was tremendous. If he knew what we know today, I'm not sure he could use that term. I'm not sure Fearfully and Wonderfully Made even begins to describe our understanding of what God has done in His design of the human body. And as I said, and most people aren't really interested in hearing this, but I had the opportunity, both at the beginning of my career as a biomedical photographer, to go into surgery, to see brain surgery. I've seen open heart surgery, kidney transplants. I've seen virtually the entire body of a living person during surgery. Of course, in the autopsy rooms, we had to take photographs of that. And then at the end of my education career, I worked for 4 years as the gross anatomy lab instructor. I was in charge of 12 cadavers that we professionally dissected. We dissected in order to teach the new PA students, the physician assistant students. And in that experience, and I would still be there had they not wanted athletics over academics, because they let me go to hire a cheerleading coach, I think was what they released me for. But that's another story. But it was a tremendous opportunity to actually firsthand study the incredible design that God built into the human body. And that's what we want to look at for about 29 minutes today. And obviously, I'm not sure I'm going to get to my invitation. So when 1 o'clock comes, I'm going to extend the invitation, or 5 till, and just call it good there, because I'm not sure. And I did have a separate, I made this condensed, so I thought I could get it in 45 minutes. Someone got long-winded in the last session. I don't know who that was. Warren, find out who that was. We'll fix these, maybe. But again, like I said, it's hard. It's hard for me to not talk about these things. And after 40 years of studying, and not for anyone else. I mean, I didn't start out my study of science to help anyone other than me. And if it's of any benefit to you, that's great. Okay. If it's not, that's fine too. It won't insult me. If you got nothing out of this, that's fine. Okay, I'm sorry I bored you, but I am entertaining to watch. I mean, falling over the chairs at the auditorium yesterday. So, but like I said, there's never a dull moment when I'm around, at least when I'm teaching. So, but hopefully it will be of some use to you as we look at some parts of the human body, and again, just a very little bit. The human body, of course, made up of cells, about 100 trillion cells, and each of our cells, or combined, have about 10,000 known functions. Now, obviously, we don't know everything there is to know. Each cell has about 1 billion bits of data. That's information stored inside the cell, and that's as much as 10,000 encyclopedia-sized books would contain. Each square inch of the human body contains about 9 feet of blood vessels, 600 pain receptors, 900 nerve endings, 36 heat sensors, 75 pressure sensors, and 72 feet of nerve fibers. That's every square inch of our body. We have hundreds of or thousands of square inches of skin on our body, and that is just skin deep. Okay, that's not the underlying dermis and right on down. Okay, that's what we call skin deep. That's just the surface layer, and you kind of scrape your knuckle. That's what you scraped off. Okay. Is that much material. Certainly tremendously complex. The skin is the largest organ in the human body. Now, it's not one condensed thing like the liver. The liver is the biggest in one piece type of thing. Because obviously the skin has the nervous system, the circulatory system. It has well, I didn't even talk about the system to control infections that come into our skin and things like that. So the skin contains a lot of different systems, the integumentary system built into it. Well, if we look at the skeletal system with its framework, we sort of have to start at the beginning if you're building a body, and when doctors dissect to understand, they start at the skin and they go clear to the bones. They go clear down to the skeletal system. And when we taught the PA students, we started at the skeleton and were able to build up because they didn't actually dissect. We actually had that done, and we started with the skeletal system and then built the muscles on top of that, and they would go in and study the muscles of the upper limb and the lower limb and torso, and etc. But in the skeletal system, there are 206 bones in the body if you're normal. Most of us aren't normal. Sorry, I didn't mean to insult you. I know Stanley's not normal, but yeah, I can say that. He's from Dealey, and he'll get me back, believe me. Okay, but most of us aren't normal. Some of you may have Walmerian bones. You won't know that until you get a head X-ray, and they notice that right here in the back, below the occipital and parietal bones, there are 4 or 5 extra little bones in there. We don't know why they're there, but they're there. Same thing with ribs. You might have 11 pairs of ribs, you might have 12 pairs of ribs, you might have 13 pairs of ribs. Yes, I'm sorry, Adam was the only one who had one less rib. Because when Adam and Eve had Cain and Abel and Seth, each of those babies had a normal number of ribs. Because God performed surgery on Adam and took the rib out. If we could take the rib out of somebody, that doesn't mean their offspring are going to have one less rib. That just simply means that one was removed, and of course God used it to create Eve. And so the 206 bones of the body, babies have about twice that many, by the way. You know that, don't they? They have twice as many bones because the bones, the long bones, have not joined up. Okay? We talk about the soft spot on a baby's head. That's where the frontal and the occipital and the parietals haven't grown together yet. And so the bones by themselves, inch for inch, are stronger than any steel that we've ever devised. Okay? I'm talking about weight-wise and density-wise and things like that. The bones are not supposed to touch one another normally. And if they don't, they are separated by one another by the most super lubricant that has ever been imagined by man. If we could synthesize synovial fluid, we could put it in our cars and the engines would never run out. They would never wear out. They would never, because of friction, need a ring job and bore the pistons out because they burn. Wouldn't happen if we had synovial fluid in there. And those, for example, all the joints, the knee joints, the finger joints, all of our joints of our body have synovial fluid. And you can tell you got them there, and I can't do it right now, but there are some people that can crack their knuckles. Thank you. There we go. Don't do that again. That hurts me. No. But that's the bursa, which is a small sac around each of the joints. And when that happens, there is movement of synovial fluid in that little sac, and that's what's making that popping sound. And it is perfectly harmless, at least according to all medical science observations. It doesn't make arthritis, but that's what happens if the synovial fluid doesn't work. Bone starts rubbing against bone, and those nerve endings start really hurting. Okay, so the synovial fluid has started to not work as well as efficiently. The bones are also involved in blood cell production, and so the long bones of the body, the hip bones, the pelvis, are there too. The insides actually have the bone-making equipment. And so the skeletal system. Well, then if we look at just one part, the hand is, we haven't technologically come anywhere near producing a robot hand that will do what our human hand does. And of course, you have to understand that most of the muscles in the hand, if you look at the dissected version, look at the bones, and you can see the synovial tissue, the joint cartilage that covers it. Most of the muscles of the hand aren't located in the hand. They're down here. Went into surgery one time, and I was a photographer, so I had my equipment. I was over setting up out of the way. Surgeon tables was over here, and they were prepping the patient, and back over here was another table, which was a little unusual. There were 3 or 4 surgeons and nurses standing back there. And when I finally got everything together, to let them know I was ready when they needed me, I started watching, and back here, these guys are talking about, okay, put a tag on that. Put a tag on that. What's he talking about? And so I kind of, raised up to see what they were doing. And here they had a hand. Some workman had got his hand cut off, all right, in a machine. And then I got to pay attention to the patient on the table. And the patient was awake, and they were saying, okay, Mr. Johnson, I think it was Johnson, but move your little finger. His little finger was over there. But when he moved, his mind sent a signal to that muscle, then they grab the tendon, because the muscle that moves the little finger, flexes it or extends it, is up here in the arm, forearm. Okay? If they weren't, our hands would look like boxing gloves. And we couldn't move them. We wouldn't have the dexterity. And that was amazing. I just flat out, to watch. And they kept him awake while they identified, tagged, put labels on each one of those muscles and nerves and arteries in his arm. And then they sewed it back together. And it worked. Okay, it worked. That was 35 years ago. I can't imagine what they can do now. So I could talk the rest of I've only got 18 minutes left. I can talk a long time and never leave this slide. I'm not going to do that. We're going to talk about the carpal metacarpal joint. Just for a second. That's the thumb joint. Everybody knew that, didn't you? Sure. The thumb joint. Absolutely astounding what the thumb joint does. That's the CMC joint. Has 5 named ligaments that stabilize the thumb on the hand. 9 muscles move the thumb, controlled by 3 major nerves. There are 2 muscle groups, the intrinsic muscles, which the bellies are in the forearm, and the intrinsic muscles, which help to move in and out. 6 descriptive terms are used to describe the movements of the CMC joint, and the male and the female thumb joint are different. They are designed differently. Apparently, God designed males and females for different functions somehow, although we use our hands the same way, but there obviously is a difference in some part because the joints are different. This quote is attributed to Isaac Newton. I can't guarantee he said it. I've researched it and cannot find the actual quote, where he wrote it in a book, but he was supposed to have said it in the presence of several individuals at a scientific gathering, and they recorded it and said it was. So if it's not, I beg your forgiveness, but I like what it said, whoever said it. Okay? In the absence of any other proof, the thumb alone would convince me of God's existence. Can you imagine? Just the thumb. If he indeed said that, he was kind of a smart fellow. Okay? But if the thumb were enough to cause him, if he said it, to believe that God, and when you study just what that CMC joint does, the carpal metacarpal joint, what it does and the flexibility that it gives, and the movement, the dexterity, it's incredible, just incredible. Let's move on. We're running out of time. The heart, though weighing only 11 ounces on average, it pumps through about 60,000 miles of blood vessels. Blood vessels in your body, if you took them and take off running and pulled one, 3 times around the world. Okay, and that your heart is pumping through that, 11 ounces. Your heart beats 100,000 times, pumps about 2,000 gallons of blood every day, and beats about 2.5 billion times in your lifetime. Now you think, oh my, that's a powerful muscle, it never can stop working. Heartbeat takes a little less than a half a second. Just slightly less on average, 72 beats per minute if you're resting, your pulse rate. And it drops to 60, so that would be just exactly half a second. Now, what is your heart doing the other half second? If right now you were to take your pulse and, okay, 60 beats per minute, so every second, half a second it's beating, what's it doing the other half second? Not beating, it's resting. So if you live to be 50, for 25 years your heart was taking a break. It was goofing off. Okay? Get the idea? So your heart doesn't work all the time. It beats, contracts, and then stops. Contracts and then stops. Contracts and then stops. Okay? Now, it's not quite that simple because you have upper chambers and lower chambers, and these two squeeze and then these two squeeze. So, it's kind of a really strange dichotomy there. But it is basically true that your heart doesn't work all the time. All right? And tell someone, I'm going to die. Okay? It does the job that God decided to do. All right, well, let's go to your liver. The liver carries out more than 500 known functions. It manufactures more than 1,000 different enzymes and proteins. It metabolizes and stores carbohydrates, fats, and vitamins. My tongue's stopping working. It breaks down harmful chemicals. This is, folks, where the poisons in your body go. Humans, unfortunately, put a lot of poison in their body. And the liver has to get rid of it. What is the most dangerous poison? That the liver has to stop its normal functions and take care of this or it's going to kill the body. Anyone know? Alcohol. Thank you very much. Alcohol is poisonous to the body. It has no function whatsoever other than to poison the body. And certainly it does a good job at that. But the liver has to stop its normal functions to get rid of that poison. That's why over a long enough period of time, the liver finally storing all this fatty material, you get cirrhosis of the liver, or can get cirrhosis of the liver, which turns your liver yellow and lumpy and twice as big as it's supposed to be. Liver's a marvelous organ. Kidneys. 40 miles of tubing in your kidneys cleans 500 gallons of blood every day and filters out of your bloodstream 50 gallons a day. Now wait a minute, what comes out of the kidney? Urine comes out of the kidney. You mean we urinate 50 gallons a day? Well, if that's the case, I got news for you. We would never leave the bathroom. Okay? We'd be there non-stop, all but about 2 quarts. Quart and a half is put back into the bloodstream. The bad area, so it's taken out, 50 gallons come out, and 49.5 gallons go back in. All right, put the good things back in because not all of that would be waste product. Helps to maintain water balance, mineral balance, essential elements, controls blood composition and pH, helps to control your blood pressure, keeps your bones strong, and is the messenger for what tells the bones to make more blood cells. Your kidney sends a signal saying, hey, we're running a little short on red blood cells, bones, how about cranking up and getting this, producing us some? That's the kidneys that do that. Obviously, kind of handy. The brain, you possess about 3 trillion nerve cells, and the brain coordinates itself. It's got its own mechanisms in there to do that. You have about 30 billion working sections to your brain. Our brain has that many different compartments and sections. We have 3 different types of memory. Sensory memory, which is the shortest. You see something, you remember it, then you turn away, I forgot what that looked like. You have to look back. That's short-term memory, that's sensory memory. Or you hear something, or you smell something. Actually, sensory memory lasts longer because it skips the brain stem and goes directly into the olfactory lobe of the brain. The shortest is the working memory, is compartmentalized. Everybody's done it. I don't know where this door goes. But if I were to be thinking about something here and I need to go get something back there and I open the door and go in, I get in there, what happens? What did I get in back here for? That's called compartmentalization. That's in your mind, people. That is, the door is a framework and your brain actually goes, okay, I'm working here, then I go here, I jump to another part of my brain. The memory of what I wanted to get back there is back in it. So what do? I come back out. Oh yeah, now I remember. That's insane. It sounds insane, doesn't it? It sounds, but they know now that that's the brain simply organizing what it needs to keep track of. Okay, compartmentalization. That's the next longest term memory. Obviously, sometimes that doesn't last very long. Okay, and then long-term memory, working memory is consolidated by the hippocampus, which is part of the brain way back in the middle, into neural connections. Changes in this from the hippocampus to the brain within 3 months will cause permanent memories. Okay, if you want to remember how to do something or spell something or remember a telephone number, say it over and over and over and over and over and over and over. You take it from short-term memory, working memory, you put it into a long-term memory because the hippocampus says, hey, this must be important, and I'm going to stick it into a long-term memory. And unless you have neural problems that eventually, Alzheimer's, dementia, that start to lose the ability to find those spots, you'll be able to remember totally useless information for all your life. Okay, Conococheague, C-O-N-O-N-O-C-H-E-G-U-E. I have no idea why I know how to spell that. That was the street I lived on when I was in 10th grade in Williamsport, Maryland. I hated that place. I had to spell the street name when I went to school, though, you know, my address. I have no idea, so I had to write it over and over again so I could spell Conococheague. And I can't get rid of it. I'd like to. It's useless information that's stuck there because it's in long-term memory. And you know, maybe some days I get dementia, I'll disconnect that, and whew, it's gone, finally. But the memory is, we still don't know why, what, or where. The memories, how they get locked in. Is it chemicals, electrical? Your brain is a chemo-electrical organ. They still don't know. How do you remember stuff? That's crazy. Something as fundamental as memory and we don't know. Science doesn't know how it works. Well, the brain also is able to project. That means, remember, your brain feels everything. Your toes don't feel anything. But if somebody steps on your toe, your brain says, oh, that hurts. And your toe is what needs attention. And so you grab your toe, not your head. You know, but that's where you feel it. You realize brain doesn't have any pain receptors. Brain doesn't feel. I've seen brain surgery on people that were awake. Okay? They don't feel a thing. You can go ahead and lop off a big section, you don't feel it. No receptors, no pain receptors in the brain. But the brain feels everything from the rest of the body. It just doesn't feel anything from itself. Okay, it's insane. But we project back to that organ. That is real, well, something called phantom pain. My grandfather, an elder in the Lord's Church in Barber County, many years ago, lost his arm in a lumber accident. He was a sawyer and got caught in the saw and ripped his arm right off. Most of my life, I didn't know him with a hand. You know, when Grandpa I was 10, 12, you know, we'd be visiting and he'd say, my hand itches. And Grandpa, you want me to scratch your hand? And I thought it was his right hand. He was talking about the one that was gone. It still itched, because he still had those nerves that went up to the brain. And they, you know, so we have what's called phantom pain. We have phantom pain that, you know, that in many cases, when you have a heart attack, it hurts where? Should hurt here. Many times it's the first symptoms are out here in the shoulder and arm. Okay, that's phantom pain or referred pain. And the brain is taking care of all this somehow, some way. Again, you know, we don't always know all of it. Well, then let's go to the digestive system. Hollow tube about 30 to 35 feet in length, and that's if you died and it's stretched out, if the muscles have relaxed. Okay, because when you're functioning, the muscles, you have longitudinal muscles and circular muscles, and you squeeze it back and forth this way and this way. And so about 35 million glands in your stomach that produce acid and that produce protective mucus. Stomach would digest itself without that protective mucus produced by special cells called chief cells. The small intestine has a surface area of about 970,000 square feet. It's huge. We took the small intestine out of one person, it would cover more than this room. Probably, I don't know the dimensions, probably 4 or 5 of these rooms. Now, but it's only crammed into about 8 feet. But what they have is special little microvilli. You have these bumps, finger-like things, and then off of the bumps are microvilli, little bumps off of the bumps. And that increases the surface area so that we can digest, because most of your digestion, of course, our digestion is done in the small intestine. More than 50 tons of foods processed in a lifetime. The borborygmy is the scientific name for And Bob, is it time to eat yet? My stomach's rumbling. It's after my lunchtime. I'm used to eating at 12 minutes. Right? But that is what is called when there's nothing in the digestive system and we try to move by peristalsis, we try to move through. But what we're pushing around is air at that point because food's all been breakfast. That sausage and gravy was moved on, and biscuits, that's done moved on to another section of town. Okay? And so I'm pushing air around now, and I can't wait to get wherever we're going for lunch, Bob. So I'm ready. Okay? But controlling these activities, of course, is a tough job and requires a nervous system with millions of nerves. Your brain has a nervous system. Or excuse me, back up. Hello, Dave. You're getting tired. Your digestive system has a brain. Okay? Feelings and emotions. You ever heard of butterflies? Yesterday morning when I started, I had a few butterflies. I was kind of short of breath, and it took me a while to find to relax and get into, you people weren't going to hurt me. I mean, yeah, some of them look kind of vicious, but gut instinct, gut reactions, kicked in the gut. And I don't know about, I don't know if any of you ever had the obviously we're women have, but to serve in the eldership. One of the worst feelings I've ever had is when a faithful member of the Lord's church decides to turn away from the body of Christ and go. It is a pain in your gut like you cannot imagine. I mean, for weeks, and I'm not sure I'm over it yet. We still try to pray and encourage those individuals, but it just feels like somebody just, as hard as they can punch just right in the gut. Well, that's part of the brain and our digestive system. Gut fear, gut feelings. It's amazing. Underlying these sensations is an often overlooked network of neurons lining our guts that is so extensive that some scientists have nicknamed it our second brain. We have two brains in our body. We have this one, and then we have the one that controls all of this other stuff in the digestive system. This second nervous system is technically known as the enteric nervous system. The second brain consists of sheaths of neurons embedded in the walls of the long tube of our alveolar canal, our gut. And it's not one big group of neurons, it's spread out in about 6 feet with little groups of neurons that control a particular area. But they obviously have some big time activities. The second brain contains about 100 million neurons, so it's large. There's a lot going on down there, more than either the spinal cord or the peripheral nervous system. Remember, you have central nervous system, brain, spinal cord, then you have all the nerves outside that are called peripheral. All right? So all the rest of the nerves in your body and or your spinal cord don't equal the same size as this enteric nervous system. There is one nerve that runs from this second brain to the first brain. It's called the vagus nerve. And it's very, very important. And it can do some strange things to you. One night after services, we were having our song practice one Sunday night. I had just finished. I was doing the invitation song. Started feeling bad. I had my son take over and lead the invitation song. I went out and immediately ended up on the floor when we had an EMT in the congregation got to me. My eyes were rolling back in my head. I was great. He thought I had died. He thought I had died. Turned out I had a stomach virus that was affecting the vagus nerve. The vagus nerve goes by the heart. And it was cutting down, it was shutting off my blood pressure. And because of the nervous system, because of the stomach virus that I had. So it's a major nerve that runs in our body. 90% of the nerve signals from the vagus nerve go up to the brain. Now, that means which way is more of the signals going, up or down? Most of them are going up. The gut is telling the brain what I'm doing. What he's doing down here is being sent up here. I just want to give you a heads up what's happening, okay? So that's what the enteric nervous system does. All right, this indicates the second brain communicates actively with the upper brain, telling it what it thinks it should do, what's going on. Current research is investigating how the second brain controls the body's immune system or response. After all, about 70% of our immune system, to fight off bacteria, is aimed at the gut because that's where we take in most of the foreign invaders, the pathogens that get into our body. So that seems to be what this second brain system, second nervous system brain is for. The second brain cannot second guess itself. It does not contain reasoning or analyzing abilities. Second brain being studied for its connections to the physical and health problems like autism, irritable bowel syndrome, depression. Can you imagine if we could cure depression by doing something to your digestive system? I mean, that's a horrible disorder. I mean, it's a major problem. I know individuals with severe depression, and it's life-altering. I mean, it's bad. But it could be something happening in their digestive system, not in the neural system of the brain. But feelings from the second brain are called intuition and are not totally understood by science, but seem to have a serious role in what we think and over our overall health. Your gut feelings are unfiltered. When you have a gut reaction, your brain doesn't say, well, now, you know, I shouldn't say this because that might offend this person. It just comes out. Whatever it thinks, it happens. And so you thought all of these kinds of things was just in your head. It's not. It's in our gut too. That second enteric nervous system, second brain, has some major roles in, you know, what we do and what we think. So when we look at the psalmist, okay, and I am going to be able to finish in this area, and almost in the time I'm allotted today. Okay, I pulled out, you know, several slides, and so this was a separate sermon, October 25th to Belington. Okay, was put in there. When I consider the heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him, and the son of man that thou visitest him? For thou hast made him a little lower than the angels, and hath crowned him with glory and honor. Psalms chapter 8, verses 3 through 5. When we look at a statement like that with what God has said, what the psalmist revealed, his understanding, and then what modern science shows us about the complexity and the design, and again, there's about 45 other slides about other parts of the body, the systems, and how they function together. That wasn't in that sermon because it was a sermon, you know, 35 minutes or so. And yet, then we see that, you know, the psalmist, you know, why did you make us in your image? You know, of course, in the world today, the evolutionists want us to think that instead of being just a little lower than the angels, we're what? Just a little higher than the apes. Well, I don't care what you want to be. I want to be a little lower than the angels. I don't want to be a little, you know, made in the image of a little better monkey or primate. It wasn't a monkey, a primate. But I would rather be just a little lower than the eternal beings that are in heaven with God right now, the angels. And so today, as we finish up this opportunity to look at a little bit, the question is, what are we going to do with our brain? Does your gut tell you today that you need to respond to the gospel call, to be obedient to the gospel plan of salvation? You know, if your gut's telling you, and I have seen people, and I probably was like this before I was born, hold on to the back of the seats. When the invitation song, hold on, because I don't want to do it. I know I should, my gut tells me I need to, but they just fight it and fight it and fight it. And I hope they don't fight it too long. Because just like anything else in our bodies, we tend to get kind of used to things. Our conscience gets seared and we don't act on it. But if you have that gut feeling that you need to be obedient to the Lord, we've heard, not necessarily the gospel plan of salvation all this week, but the concept that God is and that God has a plan, and that plan says that we need to believe in Him, we need to hear His word, we need to confess, we need to repent, and then we need to be baptized. If you have a gut feeling that I did that and I didn't do it, I didn't know what I was doing. You know, between you and God, if you feel like you need to be rebaptized because you're not convinced, your gut tells you I didn't know what I was doing. Don't let that go either. You know, it's always, as Mike says, better to be safe than sorry. I mean, if you're not thoroughly convinced. But if your gut feeling tells you that I haven't been what I should be and I need to fix that today. Now we have the opportunities. We sing the invitation song. If you'll come, always stand and sing the song, select, and let your needs be known.